The purpose of today's lesson is to learn more representations of a linear context. So in the following problems, we're going to be given one of the representations of a linear relationship, and then we have to complete the 3 remaining representations. We have to label our columns, our table, and our axis. Okay, first one is you and your friends go to the state fair. It costs $6 to get into the fair and $2 each time you go on a ride. Consider the relationship between number of rides and total cost. Right? So they are giving us the 2 columns here. This is the number of rides, and this is going to be our cost. And that should be in dollars. Okay, number of rides. So if we go on 0 rides, how much is it going to cost? Well, it's $6 just to get in and $2 each time. Remember, we like the words each. That kind of gives us a hint for our rate of change. So 0 rides, no rides, it's going to be $6. If you go on one ride, well, you paid the 6 and then you have to pay the 2, so that makes it 8. 2 rides, you've got 2 more bucks you have to pay, so that's going to give you 10. And what you'll start to see is there's a pattern, so you're adding 2 because that's your rate of change. So let's finish the number of rides, and this would complete the table. All right? Then we're going to graph that. And we have to label the numbers, and it looks like anywhere from 0 to 5, and I'm going up to 16. So you have to keep that in mind. And remember, the X always goes here, and that was the number of rides. And over here, of course, is the cost. I'm going to pause it and label these. Okay, this is what I came up with. So if you started to hear it 2, you're not going to have enough markings to get up to the 28. We had to get up to 28. I guess we didn't have to, but I did. Alright, so starting point is 6, so we're going to make a dot there. Starting is 6, and then at 1, we're at 8. So we're going up 2 over 1, up 2 over 1. It just is quicker and easier to go this route. So we'll go ahead and show our line. And now we have to write our equation. So I'm going to use this as my guide. Oh, it's really thick. We better thin that out a little. Okay. And we know this is our rate of change. And this is the y-intercept. So the equation is going to be rate of change was 2, and the y-intercept was, oh that's right, 6. So this would be our equation. Alright, let's look down here. We have some questions that we have to answer. What is the rate of change in this problem? What does the rate of change represent in the context? Well, the rate of change is plus 2, and that is the cost per ride. What is the y-intercept of your graph? Okay, 6. We'll name it as a point, 0, 6. Where do you see the y-intercept in the table, in the equation? When x equals 0. That's question 2. What does the y-intercept represent in the context? It represents the cost to go into the park. And no rides. That's just your entrance fee. That's what that represents. How would you change the context so the relationship between total cost and number of rides can be modeled by the equation y equals 2x? So now we're not going to use the y equals 2x plus 6. We're eliminating that. And we're changing it to this. So what would the change be? It would be free to get in the park. It would be free to get into the park. to the park, but you still have to pay $2 per ride. Okay? How would you change the context so the relationship between total cost and number of rides can be modeled by the equation y equals x? Alright? It cost $6 to get in, and all rides, how much would they cost? Nothing, are free. Alright, our next problem. We're taking a road trip. You start the day with a full tank of gas. Your tank holds 16 gallons of gas. On your trip, you use 2 gallons per hour. I like this word, per. Consider the relationship between time and hours and amount of gas remaining in tank. Okay, so they're telling us what our relationship's all about. This is hours and gas remaining in tank. Remaining in tank. And we do need a label for that, and that's gallons. Okay. So if there's 0 hours, we're starting out. What are we starting with? Well, 16 gallons of gas. After 1 hour, we're losing 2 gallons of gas. 2 hours, we're losing another 2, and so on. So we can finish this up. 16 and 18. Let's keep in mind what's happening here. Our rate of change is losing. So we're going down -2, and these are all constant. Right? And then, of course, we're going to graph this using our numbers. So let's start with a label. Time is in hours, and this is remaining gas. Remaining gas, and this is in gallons. Let's just use the same numbers we used previously, 2, 4, 6, 8, and 10. And let's go up by 4s. I'm just going to go 4, 8, 12, 16, okay, and 20. Let's plot these points. I like using the thicker marker. At 0, it was starting at 16. Oh, excuse me. We're going down 2. Now remember, these are going by 2's over 1, down 2 over 1, etc. Let's keep on going here. 2, 2, there we go. Alright, so there's our graph. Connect those guys by a straight line. Saying that rather loosely. And then, of course, we need our equation, mx plus b. This is our slope. Rate of change, this is our y-intercept. So what do we have here? Well, we know it was a -2x, and where is it crossing the y-axis? There it is at 16. So we would get y equals -2x plus 16. Alright, let's answer our questions down here. What is the rate of change in this problem? The rate of change is -2. What does it represent? Well, it represents you were using 2 gallons of gas per hour. What is the y-intercept? Okay, that's where it crosses on the y-axis at 0, 16. Where do you see the y-intercept in the table? When x equals 0. And what does it represent? Well, it represents you're starting with 16 gallons of gas. So the y-intercept is always going to be relating to where you're starting. Keep that in mind. That's very helpful. How would your equation change if your gas tank held 18 gallons of gas and use 2.5 gallons per hour of driving. So we're still going to use this equation. Kidding. Let's put an m there, mx plus b. But instead of starting being 16, it's 18, and we're using 2.5. What would these changes do to your graph? Well, the line would shift up 2 units, and the slope would be steeper. So the line would shift up 2 units. I'm going to let you write that down, what I'm saying. The line shifted up 2 units, and the slope would be steeper. So I'm saying it, I'm not writing it, because I want you to write it, because you're listening to me at all times. Okay, these next 3 problems, 3, 4, and 5, I'm going to get you started on 3, but these are the ones you have to finish on your own. It's kind of like YOLO, but it's OYO. So let's take a look. We're only given one piece of the 4. We're given the table. It's talking about time in hours and the cost, dollars. Okay. I need to figure out my rate. So this is going up by 2. Alright. So it's something about $2 per hour. So my story has to be something dealing with $2 per hour. And I'm starting with $7. That's what my story has to be about. So let's say Kip has $7 in his wallet. He is going to earn $2 per hour. What could Kip be doing? Okay, he's going to earn $2 an hour for walking dogs. How's that sound? For walking dogs. Okay, you get to finish the graph part of this and the equation part of this. Okay, and then you're finishing number 4 and 5 on your own. OYO. Alright, this concludes our lesson on representations of a linear context.